Hey everybody, welcome back, and in this video we're going to explore the Solana Hello World program example. Now disclaimer, I usually say it's not development advice, but this time it's on Solana because we're going through their code, so if you're not sue anyone, sue them. So to get started, in this video we're going to go over Solana's Hello World program on GitHub. We'll be pulling down the GitHub repo on our WSL instance and then going through the code and then just deploying it on our own local host network and try to play around with some front-end JavaScript code. So on the very high level, what I want to talk about is just what the smart contract does. In the Hello World program, it's just a smart contract that does one thing. So we have Bob, our user, and then we have our Solana network. So how this application in most smart contract works is first a user needs to create an account. So Bob would send a transaction to our smart contract to create a Bob account. And maybe move my head. So the account would be initialized with a whatever data that we want to store on the network. And in this instance, we just have a count. So we'll have a default value of count 0. And the purpose of this smart contract is we want to increment this count. So Bob will send a transaction telling the network to increment. And once the network receives a transaction, it would execute the instruction that it receives, and it would just increment the count to be 1. And that's really it. That's all this code does. And then the final piece of the implementation is if Bob wants to get his account, he would just query for his account. And then when the query has been made, the network would just return the count. And then on the client side, we would get the transaction information, and then we would do whatever we need with that information. So hopefully that's simple enough to understand. This is the Hello World example that we're going to go through. So let's get started. So the first thing we need to do is we need to clone the Hello World example on WSL. So I'll include the link in the description below, but it's pretty straightforward. Go to GitHub repo, get the link, and then just do a git clone. And in fact, we can just do it. So I'm on GitHub. I probably should make there we go, make everything bigger. We just click on code over here and then copy the link. And then I'll pull up my terminal. Make this screen bigger. There we go. And we type WSL to go to our WSL instance. And then I'll go to CD squiggly line to put us in our root. Probably shouldn't have made that bigger that way. There we go. And so if we do an ls, you can see that I already have quite a bit of things, including the example Hello World program. But let's just do it from the start. And let's create a new folder called CD. And we can just do a git clone and then just paste the link. One nice thing about WSL is that Git is actually included in all instances of it, or at least most of it. So you don't need to install anything. So they get cloned, and then if we do an ls again, you can see that we have the folder now. And here's the content. So now we can work with this. I'll quickly go back to our presentation. So after we have our WSL installed, the next thing is we need to actually interact with the code there. The best tool I found to do this is to get the Remote WSL extension on VS Code, my favorite code editor. I'm going to assume we're all big boys and girls and know how to get VS Code or / have VS Code already installed. So I'm going to skip that part and just get to it. So we have Visual Studio Code. Here's my example of it. I'll make the screen bigger for all of us. And so for those who aren't familiar with extensions, you can get extension by clicking on this icon over here. And then just look for WSL, and probably Remote WSL will show up. Just click it and then install it. I recommend reading the README on how to navigate WSL, but once you have WSL installed, there is a Remote Explorer over here above your extension icon. And you can see all the projects that I have already set up on my VS Code. But in this instance, we don't have anything yet. So what you need to do is click on this Open Remote window, click on New WSL window. And now if you see right here, we are connected to our WSL Ubuntu. And so now that we are connected in, all we need to do is click open folder and then navigate to the path that we've cloned our repo in. So in this instance, that would be video and example hello road. And if we click OK, we are now connected to our cloned repo. If you look on the left side, you can see that we have our client, our C code, and our Rust code. And so now, for example, if I open up our program Rust, we can directly edit the code on our WSL instance without needing to use a text editor on our command prompt. Another helpful tool I like is we hit the control squiggly line. Alternatively, you can also go to view and then click on the terminal button over here. And this will open the, terminal. Big surprise. And one nice thing about VS Code is that you can have as many terminals as you want. So what I can do right here in this folder is I can do Solana test validator. Don't actually know if this will work. Okay, it will work. And this will run the validator node. And then I can click on this plus button right here. And this will create another instance of our terminal. And then here I can deploy my smart contract and run and build my code. So now inside VS Code, we can do everything we need to do to develop a smart contract. I highly recommend this setup, and if you have any other better setups or tips, I'd be very interested in knowing, so please do leave them in the comments below. But yeah, that is WSL installation in a nutshell. So great, now we finally have the extension and our code in front of us. We can finally actually start looking at our smart contract. Just like in any smart contract, there are usually two pieces to it. There's the on-chain code, and there's the off-chain code, which is the clients, or the JavaScript, the websites. We'll look at both, but first let's look at the on-chain code. So the code is located at the hello world repo inside the program Rust folder, sources, and it's the lib file that we just opened up. So there are multiple pieces to a on-chain code, but on the very high level, at least in this code, there are three things we need to do. The first is we need to define an account data type. This is just the data that we store on the smart contract. In this instance, we keep track of a count value that we increment inside each of our accounts. As you can imagine, in more complex projects, we have different types. And if you want to know more about the types of data that you send across the network, do check out one of my past videos in our playlist where we go through the Solana lifecycle and what is inside of a transaction. Small plug aside, the second thing that goes inside a on-chain code is setting the entry point to handle our transaction. It's literally just a macro in our Rust code that we include, so nothing hard. And the third piece of the puzzle is we need to actually write a function that would actually help process the instruction that we receive. So before we go actually look into the code, I just want to point out these helpful crates, which you can also think of as libraries for Rust. And that's the Solana Program and the Borscht, hopefully that's how you pronounce it. Solana Program is the actual library that we use to create and process smart contracts, and Borscht is just a helpful serialization, deserialization library to send our account across the network. Without any delay, let's finally look at some code. I'm going to just get rid of our terminal by hitting Control and the squiggle line. So we already opened up our lib.rust file, and you can see there's quite a bit of code. Like a good professional engineer, I am going to completely ignore our tests. For the sake of this video, I just want to focus on actually being able to write a smart contract. So the first part of code we see from line 1 through 9, this is the import that Rust uses, and I also include the links to them in the description below. If you really want to dive in deep into the APIs, highly do recommend reading it. But just so you know, we are importing these specific fields. So now we actually look at the code. So like I mentioned, there are three pieces to a on-chain code, or at least in this on-chain code. First one, we need to set a account. And this is the data that we send across the network. So in Solana's hello world example, there's something called a greeting account. And the greeting account is just a structure, and it has three attributes: Borscht serialize, deserialize, and debug. We don't really need to know what they do, but just know that this is how we extend and add a functionality into our struct. In the case of greetings account, there's only one public field called a counter, which is a integer, a unsigned integer specifically. And the part that I don't like, and we'll see more about this when we look at the off-chain code, is that in Solana, we need to define the greeting account in both the on-chain and off-chain code. And as you can imagine, in a big project, this could potentially lead to mistakes. But don't worry, in future videos, we'll look at Anchor, which will help solve this problem. Anyways, so moving on, we've defined our greeting accounts. The second thing we need to do is we need to set our entry point right over here. So entry point is a macro, which we import from our Solana Program module. And what all entry point does is it sets up your Rust code to handle the Solana Smart Contract capabilities. It's all implementation details, so no worries there. The only one thing you need to worry is we need to pass in a function to help us process the instruction that we receive from the user when they send a transaction over. And don't worry, we will go through that on the off-chain code after this. So if we look at process instruction, there are 3 parameters that we take in. The program ID, which is the ID of the smart contract. You get a program ID when you deploy your code to the network. And this is a pub key type, which I believe is some form of hash integer. I'm not exactly sure, so we have to dive into the documentation if we're really curious. The second parameter we take in is accounts, which is a slice array of account info. If you want to learn more about slice arrays, do check out the Rust crash course video I've made to get an idea of what it is. But a slice you can think of as a subarray that's been created from an array. In the context of Solana, this is important because we could send an arbitrary amount of accounts across the network, or instruction data too, actually. So now that we're under slices, we can look at account info. Account info, as you might suggest, it's just metadata and information about the account that the client has sent over. Specifically, if you watch one of my previous videos where we talk about accounts in the Solana lifecycle, it's how Solana handles states, such as the count variable that we assigned over here. But more on that later. So in the final field that we send is the instruction data, which is a slice of U8s. In this example, we don't use it for anything, but in more complex Solana programs, instructions are usually used to tell the program to do something. For example, I'm thinking on expanding upon this example in a future video, where instead of us always incrementing the value, we can send in an increment instruction, a decrement instruction, and maybe a set instruction where we set whatever value that the user includes. But that's a video for the future. So that's the parameters that the process instruction takes in. And as you can see right here, it returns a program result. For those new to Rust and not familiar with results, a result is basically a enum type that can be 2 values. It can either be an error, as in there's a problem, and there could be OK, which is our transaction succeeded. Another way you kind of think of it is for those familiar with JavaScript, it's kind of like a promise. A promise can either have the results or it can have an error type. So that's what a result is. Now going through our code again, on line 27, the first thing we do is we just make a print statement that shows up in our console, nothing too fancy. On line 30, we start going through our accounts. Our account is a slice. Slices have a helper function called iter, which essentially creates an iterator of your account. For those not familiar with what iterators are, essentially you can think of them as a class that helps you traverse through an array. Luckily for us, we don't even need to do that because Solana has helper functions called next account info. As you can see, we import that up here. Next account info takes in the iterator, and we see this question mark over here. And what this question mark does is if you look at the definition of next account info, I'll just quickly pull that up. You can see right here that it returns the type result. You can also see that it takes in the iterator over here, iterator. And as you know, as we discussed earlier, a result can either be a OK or an error. And so normally what we have to do is we have to process the result, say if it's successful, do something, if it's an error, do something else. And what this question mark does right here is that it says, I promise that the result I get is not an error, it actually is something. And if it is an error, it'll probably just crash the program. And because of the question mark, we have a clean way of just getting our values, which is the account. I'll just get rid of this, actually. There we go. Probably should have done that earlier. And so now we have the account information. Remember, this account is the account that Bob created when he when you sent the transaction. So to be clear, this process instruction is not the initial transaction that Bob sent to create the account. It's the instruction that Bob sent to increment the counter in his account. We don't write any code to actually create the account. That's just a freebie we get. So now that we got that cleared out, we have our account. So now we have our account. We can actually start accessing the information, but it's usually good practice in most smart contracts to actually validate that the data that you get is what you think it is. I'm sure there are a lot of complex things you can check, but in this example, the most simple thing we can check is to see if the owner of the account belongs to the program ID. And to be clear, whenever a account is created, the Solana program adds its ID into the owner so that the smart contract knows that the account that Bob sent over is actually a valid account. We talk about this in the lifecycle video, but Solana programs can only execute transactions on an account that is owned by it. So in this instance, if the account's owner is not the program ID, then we have an error. In this case, we just print out the message and then we just throw an error. Now, let's say that this account is not an error and it's a valid account. Then we can actually finally start doing something with our data. So from line 42 to line 44, we are trying to extract our greeting account that we set up already over here from our account and then update it. So our greeting account that we created has a function called try from slice, and which I believe is imported from the Borscht serialize. I'm not sure on that one, but luckily for us, we can always check, and we don't really need to know because we can always copy and paste. But what this function does is it takes a slice and tries to convert it into the type that we want it to be, which is a greeting account. And the account data itself is stored inside the data property. So in our account, which you can see, we took out from the iterator, which is a account info type, and we can actually just take a quick look at it. We can see that here's the account info data. Make this bigger. And then we scroll down, we can see that account info has a type called data, and it's the data held in the account. It's modified by programs. And if you look at the type of it, it's just a slice of U8. So in this instance, you can think of it as a serialized numbers that needs to be converted into a actual object that we can interact with. So all this code is doing is saying, I'm assuming that the data that is on the account is a greetings account that has been serialized, and I will convert this into a actual variable that you can use. And just to be specific, we call borrow on the data object to get a reference to the actual data. This is more like Rust specific things. Don't worry too much about it. The code's always the same, so you can always just copy and paste. And of course, at the very end, we have the question mark, which is saying, I promise I know what I'm doing, so give me the greeting account, or throw an error. So we have the greeting account, and it's important that we set this mute keyword, and this allows us to modify the variable. Without it, we can't do any modifications. So now, after all this, we finally have our greeting account. Our greeting account, as you go up, has a field called counter, which is what we see that we use over here. And all our process instruction code does is it just increments the function. Very straightforward. And that's all. And so after we have done whatever we want on the smart contract with our account, and you can imagine this can be more complex, like we want to withdraw specific Solanas associated with the account or do some NFT transactions. You can imagine this is where all the logic is. But in this case, we're just updating a counter variable. And then finally, after we're done updating the account, we need to save it by serializing it. And that's exactly what line 44 does. We just call the serialize function of our greeting account, and then we just give it the instance of our account data that we want to essentially put the data into. Don't really need to understand too much. This is just what we do. And then after we've serialized it, we're pretty much done at this point. In this code, we just print out the new counter value, and then we just return OK as a program result. And that's basically all we need to do in this program result. We get the account that is sent by the transaction. We extract it out by using this iterator and this next account info. We check to make sure that the account is associated with this program, and then we apply whatever logic that we want to our account that we received, which in this instance, it's just increment our counter, and that's about it. So this might seem complicated at first, but I promise if you look at enough smart contract examples, you'll see patterns show up, such as how we iterate through accounts, how we get accounts, and possibly how we update our accounts. So it's as they always say, practice makes perfect. And that's basically all that is involved on the Rust on-chain code. So next up, let's look at the off-chain code that actually writes the transaction that and sends it across the network to our Rust program. Now let's talk about the off-chain code. It's located inside the source client folder of our repo. It's a Typescript code that sends a request to Solana. The nice thing about this is the npm setup that we have just runs the code. It doesn't actually deploy a website or anything. We will look at updating that in future videos to create a nice little UI for us to use. In this example, I think there's actually like 5-6 functions involved in the code, but at least in this code example, there's 3 main things that we will need to do, which is first, it needs to create an account, which we saw in the Bob example. And then once we have an account, we need to do something with it, which in this instance is increment the account value. And then of course, once we did something with our account, we might have to query the information. So we also have a query example to get the state of our account from the blockchain. So in this example, we actually use the wallet that's associated with your Solana command line. In future videos, we'll look up setting up integration with Phantom Wallet to actually interact with users that is not yourself. And of course, for those who are curious, I've also included the link to the JavaScript library that we use to write our code. So without any delay, let's get started. All right, so this is the on-chain code. Let's move on to the off-chain code. So if we just open up our Explorer again, our on-chain code is located over here in the client. There's 3 files, the hello world TS, main TS, and utils TS. We'll look at the main TS. In the main TS, and this is actually quite a bit, so let's make this a little bit bigger. Actually, we can make this bigger. Okay, and so in the main.ts, we have the main function. If you scroll down, we call the main function right here, and then after it succeeds or fails, we do the appropriate action. We don't really need to worry about that. The important part is that we are executing the code. So inside the main function, we print our code, nothing's too surprising here, and we call these 5 specific functions. They all have a wait because this is all asynchronous code because we are waiting for network connections to finish, and that could take some time. So before we can execute any of this code, we need to ensure that each of our network requests has been completed. So there's establish connection, establish payer, check program, say hello, and report greetings. So let's take a quick look at all 5. So all of that code is located inside the hello road. I'll just keep both of these open and utils. So if we look at the hello road code, you can see that we import a lot of things again. This is the Solana provides a Web3 JavaScript library that includes all sorts of things. And then there's some file pathing libraries that we'll use in this example. Normally in a Solana smart contract that you actually deploy, you most likely shouldn't be doing these types of things, but we'll just go through it. And of course, we have our Borscht library that helps handle serialization. And of course, we also import some code from our util file that we created over here. So let's take a look over our fields. First, we have connection, which is a class that we import from our Solana library. This is very important because it helps us connect to our Solana network. And then we have fields to keep track of who is paying for the transaction, i.e. the user. The public key to the program that we've deployed on the network. And of course, the public key to the account that we are storing on the Solana network. So if we continue scrolling down, we see other code like program path, the SO path, the key pair path. I recommend just ignoring these. We'll see as we scan through the code, but these 3 fields are mostly used just to help they haven't deployed their contract properly or something along the lines of that. So I wouldn't worry about this. Now, scrolling down again, we can see this greeting account. Should sound very familiar, but the greeting account is a direct mapping to the greeting account that we create in our Rust file. As you can see, the greeting account data has a field called counter. It has a constructor where we define and create our class. Nothing too surprising. And we scroll down again, we have this greeting schema. This is a map that we define ourselves that follows essentially this format. I wouldn't worry too much about it, just copy and paste. It's going to be used in our next function, which you see right here, called greeting size. And then we'll use the schema and our new account type to serialize and get a length of the byte array that we need to use to send across the network. Quite convoluted, but it's just what it is. One thing I just really don't like, to reiterate again, is the fact that we need to have the exact same implementation on both the Rust side and on the TypeScript side. But once again, anchor to the rescue later. All right, so remember we have 5 helper functions. The first one is we need to establish a connection to the network. And to do that, we need to create a connection from our connection object. We need to give it a URL, which we create from calling get RPC URL, which is inside our util file. If we look at the code over here, you can essentially see that we go through some config files to get the URL. Maybe if the code is looking on the devnet or localhost. In this instance, it doesn't matter. What we're really going to be working with is our localhost instance, which is localhost at port 8899. I probably wouldn't pay attention to most of this. Just know that we are getting the URL to the network. And of course, once we have the connection, we can start sending transactions and things like that to it. And of course, as you notice, we are storing our connection as a global parameter over here. All right, so next up, we need to establish a pair. So in this function, all it essentially does is it gets the user's wallet and then checks to see how much it costs to send a transaction. If the wallet doesn't have enough Solana, it would just airdrop some. This is mostly just a helper function to remove some of the processes that's involved. But in the real world, we would actually have to write the code ourselves to connect to a wallet or something and inform the user if they don't have enough Solana to pay for the transaction. But let's just take a quick look into it. On line 101, if we don't have a payer yet, because this is probably our first time running this code, we need to create one. And all this does right here, from line 102 to 108, is we are trying to calculate the fees that's associated with sending a transaction. Now, I won't go too deep into the fee calculation, partially also because I really don't know how it's calculated, but you can imagine if you want to do something similar, you would just copy and paste. And then we call the get payer function to actually set the payer so that we can create our account. Get payer, if you actually look into it, it's just a function that reads your Solana command line to get the wallet that's associated with it. So as you can imagine, in the real code, this would be us calling Phantom Wallet or something. And now that we have the payer's account, the next set of code from line 113 to 122 is essentially us just seeing the balance on the account. And if it's lower than the fees, we just airdrop some Solana into the account so we can do the rest of our transaction. So like I mentioned earlier, this whole function is just a helper to ensure there are less processes that beginners have to go through to get their code to work. So great. Our next function is check program. And now we're starting to get closer to the actual meat of the code. I would ignore the first 2 if statements from line 137 to 160. All this is helper code from the devs to ensure that beginners set up everything properly. Like maybe they forgot to make a key, or maybe they forgot to deploy the program. In theory, they're accessing files that we get from deploying Rust, and normally a front end would never have access to it. So we wouldn't even be able to replicate this code in a real environment, even if we wanted to. So skip all of that. Don't worry about it. So on the very high level of this program, this is the part of the code where we first create a transaction to create a Bob account. And to create a transaction, we need to create a public key that we want to associate with our account. And to do that, we call the public key class that we imported from Solana's helper library. And it has a function called create with seed. And all create with seed does, it takes the public key of the payer, a seed keyword that we want. It doesn't really matter what it is, but in this instance, it's just a hard-coded hello. And then the program ID that's associated with the code that we deployed. And this will give us a public key that we can use for our account. And because this is a function to create with a seed, and we give it a public key and a program ID, the seed will always be unique to our user. So great, now that we have a public key, we can check if it exists on the Solana network. And we do that by calling this getAccountInfo function with our connection, and we just give it the public key. And like I mentioned before, because the create with seed function will always create a unique pub key that's associated with the inputs that you give it. If you find a greeting account, which specifically if it's not null, that means that this is not the first time we create the account, and we can essentially just not execute any of the code in our if statement and just end this function. However, if it does return null, that means this is the first time we've actually ran this code, and we've never created an account that's associated with our public key for this program. So we need to create one. And to do that, we simply just need to create a transaction, and we'll talk about the LAN ports later. And inside this transaction, we need to actually create our account. And of course, there's a helper function called system program that we import that would help us create an account. I won't go into all the parameters that we paste in. I won't go into the details of all the parameters that's used. I think you all can kind of copy and figure out your way into this. But one thing I do want to point out is the LAN ports. So as recall from the Solana lifecycle video, whenever we create an account, we need to pay rent, so to speak. And rent essentially is just LAN ports, which is just a small fraction of Sol. How the Solana network works is that you need to pay for your account to stay in the network. And after every cycle, whatever that is defined as, each account would lose some LAN ports. And once the LAN ports hit 0, Solana would clean the account from the network. What we need to do is we need to add sufficient amount of LAN ports, or we can also make the account rent exempt so that essentially it will always be in the node and it can never be removed. I also do want to point out that from the Rust example, I may have given the impression that when they send the account over, that they are also sending the data, like the counter. But that is actually not the case. All of that data is stored on the network. So the client side can't actually do any manipulation with it. All the client side has is the pub key that's associated with their account. So long spiel over. So that's about it. So we have a transaction, and then finally we just call another helper function called send and confirm transaction. We use the connection to our network. We send the transaction that we just created, and then we send an array of the people who are paying for the transaction. Like always, it's just copy and paste. And that's all you need to do to create your initial account. So we created the account. Now we want to actually send a transaction to increment it. And that's what this say hello function is. And it's actually pretty small and straightforward, which thank goodness. So I also mentioned in my Solana lifecycle video, the smallest bit of data that's associated with a transaction is something called a instruction. And if you recall, inside our Rust code, we have a function that processes the instructions. And if you actually look inside what we are passing inside our instruction code, it might actually seem very familiar. We have our keys, our program ID, and our data. So what does that seem familiar? Well, we get the program ID, the keys are our account, and data is our instruction data. In fact, I'll actually pull this up from our librs. If you look at process instruction, you'll see these exact three same things. So this is where we define it. In our keys, we create our accounts. We give it the pub key of the account that we've created already and stored as a field. And then we add is signer and is writable. These are just extra params. You can read more about them in the Solana documentation, or once again, check out that lifecycle video I made. But one of the important fields over here is writable equals true, which means can the Rust program edit the account? We have to set this to true, otherwise our code will probably fall apart. Anyway, so outside of that, in our instruction, we also include our program ID, and then we also create a null data. Like I mentioned in the Rust section, this data field can include metadata that will help us figure out what to do with the account inside our Rust program. In a separate video, we'll actually update this to actually include instruction data, but for now, we just don't do anything. We always just increment our accounts by 1. Once we have our instruction, we just do the same thing as we did when we created our account. We just send in confirm transaction, we give it our transaction type, we give it a new transaction, and we add our instruction. And of course, someone has to pay for it because this ain't no charity. And so once this say hello function is executed, our Rust code would process the instruction that we sent and then increment our counter by 1. Things are actually starting to finally come together. So finally, after sending the instruction, we increment our counter, but we want to see our end result. And so for our fifth function, we have something called report greeting. And what this does is it gets the account data back from the network. As you can see, we call this our connection.getAccountInfo again. We're probably seeing this quite often now. And then we give it our pub key to our account that we stored on the network. And this gives us the account info. If it's null, that means we either never created the account or possibly the account has been removed because we ran out of rent. In this instance of the code, that'll never be the case because it's always the last code that we'll run. So we have the account info, but the problem is that the data that's associated with the account, just like in the Rust code, is completely serialized. So we need to deserialize that into a type that we understand, specifically our greeting account type that we created. So we just give it the schema, give it the type we want to convert to, and then give the bytecode that's associated with it. We call borscht.deserialize, and then we get the data type. And that's it. Now we have our greeting account. Inside console.log, all we do is we call greeting.counter, and we get how many counters we have incremented our account by. Hopefully, it's not too bad once we actually start sinking your mind to it. And after going through the code line by line, it definitely took me multiple iterations before things started clicking in. So I recommend you to do so yourself if you want to, and maybe reference this video to kind of understand what is happening. So that's it. Great job, everybody. We've completed the on-chain and the off-chain code. So now it's finally time to deploy the code and see what happens. So, oh boy. Okay, here we are. So deploying the smart contract. There is a I think 6-step process we need to follow, but generally just follow the README in the repo. I'll tell you exactly what you need to do. But first, we need to set our Solana to be localhost because we don't want to actually deploy anything, which could be especially disastrous if you have Solana in your account and then you actually deploy it to dev main. Please don't do that. You need to call Solana keygen new to create a key pair later that we will use as the pair. And then finally, once you have all that, just call Solana test validator to start running a local node. This is important because we need to deploy our code. Now, once that's up, in parallel, we could also run npm run build program Rust. This will run cargo to build our Rust program. I'll actually show you the package.json later to see what this is associated with. And once that's done, it would create this program hello-world.sl file that we need to deploy to our network. And we do that by calling Solana Program deploy and the path to our hello-world.sl file. One step I actually forgot is I said that we need to do npm run start to run our client code, but we actually first need to do npm run install. So we download all of our dependencies for the off-chain code that we just went through. And then after that, we do npm run start. And of course, final disclaimer, if you ever decide to update the on-chain code for your own fun, you have to rebuild the program to generate the new SO file, and then you have to deploy it on the network. So without any delays, let's get started. All right, so let's open up our terminals again. We go to View, Terminal. Luckily for us, let's actually stop our validator. I believe I might have already set Solana to be localhost, but in the event that it's not, let's just change it. Afterwards, we need to create a new key pair. Specifically, this creates our wallet that we store Sol in. So that's this command. I already have one, so I'm not going to run it, but you need to do this if it's your first time. And of course, now that we have done all that, we can run our Solana test validator to deploy our network. And then now, if you hit the plus button, you can create another terminal. We have to keep our validator running. So back over here, we need to start building our code. So we do the npm rust. We do npm run build and then program rust. I'll run it, but let's actually quickly take a look at our package.json. For those not familiar with JavaScript, this whole build setup is part of npm, which is a package manager, and you can define specific commands to execute code. So if we look down here in our scripts, we see that there's this build program rust over here. If you look at this code, you see that it would run the command cargo build, and then it would give us the path to our Rust program. And so if you watch the Rust video that I've made, man, I didn't even intend to promote these videos, but they're actually so handy. But if you watch the Rust video, you know that Cargo is also a build manager tool for Rust to deploy Rust code. But anyways, so we deploy the code. So now we are ready to deploy the code to our network. So we deploy our code, which is Solana Program deploy, and the path to our hello world.sl. We give it some time as the code deploys, and now we're done. So there we go. We finally deployed our program. Yippee, we've done a lot of work to get to this point. We're almost ready to actually run it. So now that our program is running in our local network, we need some client code to interact with it. So first we need to do npm install to install the dependencies inside our Typescript files. And now that we've installed all of our dependencies, it's time to actually execute our code. We do npm run start. And there we go. We have all this information. If you look in our logs, using our account, which has 4,999, well, maybe 4 million. We have a lot of souls. We are connecting to our program that we just deployed on the network. And then once we incremented it, which you can see in this part of the console log right here, we query the account again to see what the counter is, and it's 1. And if you run it again, you'll see that we're actually incrementing it because all this data is stored on the network. And that's it. Congratulations, we have done it. We have created our first Solana program. And to prove that this connection is actually being made, if I were to terminate this terminal and we hit npm run start again, we get this error because there's the thing we're connecting to. So congratulations, after 4 videos, we've finally done it. Created a Solana program, deployed it on our Solana network, create some client code that will interact with our program, and then executed everything flawlessly. So great work. I think we all deserve a long rest, but it's not over yet. We're only literally just touching the tip of the iceberg on this. In the next set of video, we're going to look at expanding this hello world example to actually take in instruction data and doing slightly more complicated logic with it. But until then, if you found this video helpful, please do me a favor and like and subscribe. But outside that, once again, great work, and I'll catch you all in the next video.